Okay, guys, in this lesson, we're going to learn how to graph quadratic functions by finding some key features. So let's talk about the parts of a quadratic function as an equation and then also its graph known as the parabola. So here we have standard form of a quadratic function, and we know this is quadratic because our degree is 2. So when we have a function whose equation has a degree of 2, we know this is considered a quadratic, and when we graph it, it is going to create this parabola. So what it means to have a degree of 2, it means that there are at most 2 possible solutions. So when we studied linear functions, our degree was 1, and we had at most 1 possible solution. And when we're talking about solutions, remember we're talking about where our graph intersects on the x-axis. So you can see here that this quadratic function, y equals x squared minus 6x plus 8, does indeed have 2 solutions, and these are the x-intercepts. And then whenever we are talking about the graph of a quadratic, again called the parabola, all quadratic graphs have the shape of a curve. So it looks like a U, but as you can see, the graph continues to go left and right. Our graph is not straight up and straight down. It gradually extends left and right. So the parabola shape is a U shape, but again, the graph gets wider and wider. Okay, now let's talk about the difference between this parabola, here's its equation, compared to this parabola. And so what do we notice about these two parabolas? Just looking at the graph, we can notice immediately that this graph turns up and then this graph turns down. So it increases and then it decreases and it turns down, where our first graph turns up. So in this function, we can see that our a value is an understood 1, and in this function, our a value is an understood -1. So our a value being positive indicates that our parabola turns up, creating a vertex that is the minimum point, which is the lowest point of our graph. When our a value is negative, our parabola turns down and our vertex now is the maximum point. It is the highest point on our graph. So when our a value is negative, our vertex is a maximum point. And when our a value is positive, our vertex is considered the minimum point. And remember, a vertex is a point on the graph, and a point on the coordinate plane is 2 values, the x value and the y value. So this vertex is 3, -1. So again, points on a graph are ordered pairs, and all ordered pairs have 2 values, the x value and the y value. The vertex on this parabola is going to be 3, 1. So again, let's review. When our a value is a positive, our vertex is the minimum point. It is the lowest point on the graph. And when our a value is negative, our vertex is the maximum point, the highest point on the graph. So let's look at the parts of a parabola. Again, the name parabola is the graph of a quadratic function. So let's take a look at our first point. And this is where our graph, our parabola, crosses the y axis. So this is the y-intercept, and we're going to write that as an ordered pair. The y-intercept, again, is a point, and we write a point on the coordinate plane as a coordinate x comma y. So this is 0 comma 8. All y-intercepts is when the x value is 0. Then we have our x-intercepts, and we have 2. And our x-intercepts, we're going to write as ordered pairs. So this is going to be 2 comma 0 and 4 comma 0. So x-intercepts is when the y-coordinate is 0. Then we have C, this vertical line. This splits our parabola into 2 mirroring parts. It is symmetrical about our axis of symmetry. So the axis of symmetry, also we call it the AOS, is a line, and we can't just put a value. We have to write this algebraically as an equation, and all vertical lines are x equals whatever x value it passes through. So this vertical line passes through x equals 3. Now you can remember that every ordered pair on this line is going to be, for example, 3 comma 9. This point is 3 comma 8. This point is 3 comma 6, and we can keep going on and on. And 3 comma 4. So we can see where it is. X is 3. X is 3. So that's where the equation comes from. All of the coordinates, the x coordinates, are 3. And then we have our vertex that we have already spoken about. So our vertex, in this case, again, it is an ordered pair. So we're going to write our vertex as 3 comma negative 1. And the vertex in this case is going to be a minimum point. So I always like to indicate if the vertex is a minimum or maximum. That will help us when we do other key features. So let's review that the y-intercept is a point, so we write it as an ordered pair. Our x-intercepts are also points, so we're going to write those as ordered pairs. Our vertex is another point, so we're going to write that as an ordered pair. So we have 1, 2, 3, 4 points of a parabola, and usually 5 points is a good amount of points to create a parabola. And then lastly, our axis of symmetry is a line, and it is the vertical line, and we write it as an equation, x equals 3. Now let's just notice one other thing. We can see if you were asked to find another point on this parabola, of course we could pick any of these, but let's just take a look at, for every point to the left of the AOS, there is an equally distant point to the right of the AOS. So this y-intercept is 1, 2, 3 units from the AOS. So then this corresponding point is going to be 3 units, 1, 2, 3. So we could identify the corresponding point of the y-intercept, and this is point 6 comma 8. And we can see on down the line, here we have a point 1 comma 3. It is 2 units from the AOS, and its counterpart is 2 units from the AOS. So you can see that besides the vertex, every point to the left of the AOS is a corresponding point to the right, and they are equally distant from the AOS. That's super important to remember. Okay, now let's look at some key features without a graph. So we just viewed some key features when we had a graph. So graphically, we could identify those key features. Now let's do algebraically. So we're going to look at this function, quadratic, identify our A, our B, and our C. And then I want to give you some formulas that you will write down to identify these key features. So the y-intercept, remember, is an ordered pair where your x value is 0. So the y-intercept, we simply, to get the y value, we insert 0 everywhere, everywhere we see the x. So I inserted 0 here and here. And then when we do the math, 0 squared is 0. Anything times 0 is 0. So we're left with our c value. So the y-intercept, you can conclude that the y-intercept, when written in standard form, is the c value. Now, we're always going to write it as an ordered pair though, 0, 8. So this is our y-intercept. So 1, 2, 3, 4, 5, 6, 7, 8. So if I were asking you to give a sketch, you could start with that point here. Next, we're going to find the x-intercepts, and the x-intercepts is when y, when y is 0. So I'm going to put in 0 for the y. And we're going to try to use factoring to solve this to get the two x-intercepts if we indeed have two real solutions. So there's no GCF, and so A times C is 8. My B value is negative 6. So what times what is going to be 8, and then add up to negative 6. So we're factoring. So I'm going to factor x squared into x and x. And then we're going to factor 8 into, we could say, negative 4 times negative 2. That gives me a positive 8. And then it also adds up to negative 6. So we're going to do the quick trick because remember, when A is 1, we don't have to go through all the grouping process. So x minus 4 and x minus 2. And then we set each of these equal to 0. And we're going to solve for x. So we're going to add 4. Here we're going to solve for x and add 2. So we have 4, 0 and 2, 0. And again, if we were doing a sketch, 1, 2, 1, 2. And then we had our y-intercept, 1, 2, 3, 4, 5, 6, 7, 8. So we would have 3 points. The other thing that I always take note of is the direction. I know this parabola is going to turn up because our A value is positive. So that's another thing to take note of. Okay, the axis of symmetry, the AOS, where our parabola is divided symmetrically. So the formula for the axis of symmetry, again, it's an equation. It is the equation of a vertical line, so it's x equals something. So it's x equals negative b over 2a. And so we will identify our a, b, and c value. It's written in standard form, so 1, negative 6, and 8. So this is a formula that it may look familiar. It's the front part of the quadratic formula. So this is something you will need to memorize. And so our axis of symmetry, again, is a value of x. So x equals negative from the formula, and then the b value is negative. So this is where you need to be careful. This negative comes from the formula. This negative 6 is my b value over 2 times a. So x equals negative times negative, that's positive 6 over 2. So we get x equals 3. So if we were sketching this, 1, 2, 3, here is the AOS. Now, I wanted to point out that the AOS value is the x coordinate of your vertex. So our vertex, we already have half of our coordinate. So a vertex is an ordered pair, x comma y. So to get the x value, you simply use the formula to find the axis of symmetry because those are the same value. Because if we're going to find the vertex, it's going to lie along this axis of symmetry. So it's going to be 3 comma something. So to find the something, to find the y part of our vertex, we are going to take the x value and insert it into our function. So the y value of our vertex is taking that axis of symmetry value 3 and inserting it into our function. And then order of operations, positive 3 squared is 9, negative 6 times 3 is negative 18, plus 8. So we have 9 and 8 is 17 minus the 18, so the y is negative 1. So coming back over here, our AOS, our vertex is 3 comma negative 1. We knew that 2 and 4 were our roots, and then 1, 2, 3, 4, 5, 6, 7, 8, because we know our C value is the y-intercept. And then we know that this y-intercept is 3 units from the AOS, so then its corresponding point is 3 units on the right side. So now we have 5 nice points to create our parabola. And this is one way that you can graph a quadratic function, which is finding the axis of symmetry, the vertex, the y-intercept, and any x-intercepts. And again, it's always nice to know the direction, which is all about the value of your A. If it's positive, it turns up. If it's negative, it turns down. And then we do have another way that we can graph, and we will talk about that later.